Hi everyone, welcome back. In a previous video we were dealing about tracking a billiard ball. So in that video we were drawing the path of the moving moving billiard ball. So to remember that example, first of all we were selecting the target object which we want to track, and after that we were just continue, and in the next steps it was trying to track this white billiard ball. So it was tracking. Actually in here we were not using any template matching. We were just using a simple optical flow output, so it was giving an output to us. So we were making some algorithm, some kind of playing, so it was tracking accordingly, morphologically it is tracking. So it is not using any template matching kind of thing, so it's not also accurate, but our target was just using an approach about tracking an object. So in this video, since we already learned about this Kalman filter things, I want to implement a Kalman filter algorithm into our this tracking billiard example also. First of all, to remember our Kalman filter, for example, there is a white ball in here. We were trying to track this white ball in our simulation which we created. Also, the people who are directly watching this video, maybe they can check these things. And so I want to implement these similar things. For example, the red is gonna be the future state of our moving target, which is gonna be billiard ball in our case. So also I want to put the same thing into our example, so we can also use this Kalman filter in a real example. So that's my target in this video. First of all, I want to take all these initializations things of the Kalman to another example, which is at the beginning of this one, and this is done. I don't need these things. Okay, also I can put this example that since both Kalman and this tracking project is already in my GitHub page, but I can also put this combination into my GitHub so you can directly copy. Anyway, this is gonna be the initialization. I don't want to state pos in a clear point, so maybe we can initialize this in a 0 to 0. So after kind of frame, after a few frames, we are expecting it to adaptate by itself. So we are initializing 0 to 0 for all is gonna be 0. And state post is done. Maybe we can initialize predicted position, which is gonna be the current Kalman position. Also I want it to maybe the future predict, which is red circle in the simulation. Okay, and this is done. So the next step, I think there are two steps. The first is gonna be the prediction, which is in our tracking projects we were doing that. Actually we are pushing the target, which is we are drawing the path of the ball. So we are doing that in here. We are pushing to the vector, so at the end we are just drawing. And here maybe we can just calling that predict function by this one. And after that, predicted position we already defined at the beginning. And after that, the measurement is gonna be coming from the we are just pushing this point into, so the same point we should give into this measurement, which is gonna be this one is the first one, which is gonna be the x, and the second one is gonna be this one. So since we are drawing according to this one, and okay, after that we are gonna correction, and when all is done, I think we are gonna also we can also iterate little more this Kalman state, and we can get more feature prediction, which is in here 10 step we are already iterating. Then the same thing we can also do in here. And after this is also done, we can get the future prediction, which is in here. And okay, maybe future predict we already defined here, so no need to define again. And both is done, so maybe here we just point to f. Okay, and now we already get our future prediction and the current prediction, which is the predicted position. And when all is done, we can just simply draw a circle like in this one, so we can see in our tracking project also easily. Okay, so in here I think we are doing all the things in the colorful, which is result one. Just draw the same thing in the result. So maybe 5 is gonna be better. This is red one, the future one gonna be the red one, and the current is gonna be the green circle. So now we can rerun our tracker object. So now I think we already implemented the Kalman inside this one. Okay, I think I selected. Then let's see how it works. So we initialize in here 0 to 0 the state post. So the green is trying to update itself. Also according to the red is gonna be updated. So it's getting closer. Okay, yeah. So currently this is the current one, but the predicted one, which is iterated one, is wrong. But it's just estimating. It's coming through this one. I think the 10 time iterated position maybe it's gonna be in here, but it's wrong, of course. After that, it's changing direction. The green is trying to adapt it, but since this is not template matching, it's lost here. Maybe I need to choose very well the ROI. Sorry for that, because sometimes it's not working, because since this morphological kind of things coming from the vectors, so we are using those vectors. Sometimes it's not working perfect as it is doing now. Also, let's try again one more, and hopefully it will work now. Sometimes it's stacking since the algorithm is not perfect. Yeah, again it's not working, because yeah, let's try to choose better. Hopefully it will work now. Yeah, it's working now. Yeah, this is sorry for that, because I need to improve maybe template matching or some other kind of algorithm I need to update, because now it's just using the motion vector and we are trying to draw the path. Sometimes it's not working properly. It's normal. Also, you can check the first video of this tracking project, so maybe you are gonna understand more clearly. So our Kalman filter, in if the direction linear is working perfect. Also the red is estimating well. Also when the direction is changing, if you want to make it more faster adaptation, you need to just play around with these initialization vectors. For example, this error you need to increase accordingly, or you need to decrease these things. For that you need to watch accordingly this covariance matrix, how we are setting them. There are some videos previously I already uploaded to my channel. You can check them, and you can also adapt it accordingly for change the direction. These are gonna update faster also. My target for this video just combining. We already learned Kalman, we already learned optical flow. Now we combine both of them in a real project, so we are now able to use both of them. My new target for the next videos, maybe we need to add a template matching kind of things, or some it shouldn't use, actually this is not safe, of course. Only motion vectors from the optical flow result is not used good to track well. So some template matching I'm planning to add into this example. Also maybe other videos I'm planning to use, like car tracking or plane tracking kind of. So in the next video, see you again. I'm done for this video.